We're still taking a look here at 1.5a, graphs of sines and cosine functions. We're talking about the period and amplitude still. We're talking about just taking it from the general sine function, and we're going to be talking about changing the period and amplitude. This first example is a sheet provided that we'll actually be doing in class, so don't worry about that. But it will be in a worksheet in addition to the homework assignments out of the book that we'll be looking at. So we've got two things that it asks us to find. Asks us to find the period and the amplitude. Let's change this to a different color so that we can tell the difference between the two. So the period is defined as in the regular sine function. By the way, this is a sine function. So in the regular sine function, the period is defined from 0 to 2 pi. Okay, so the period would be 2 pi. My period for this is going to be that 2 pi, but I'm going to divide it by the number that's in front of the x. So in this case, I'm going to divide it by a 3. And so my period is going to be 2 pi over 3. So that means that from beginning of this graph to the end of this graph, it's going to repeat at 2 pi over 3. And we're going to look at how that looks on a graph and how we put that on a graph in a little bit. But you need to be able to pick it out first. Okay? Same thing with the amplitude. So the amplitude here, in order to find the amplitude, I'm taking the number in front of the graph, and I'm going to take the absolute value of it. So this is the absolute value of 2, which is 2. So the amplitude is 2, which means that from the midline of this graph, it goes up 2 and it goes down 2, which is outstanding. So then I can move to the next one. I'm looking at the period. So the number that's in front of the x, whoops, let me write it here because my marker is a little too big, is going to be 1/4. So the number in front of that x is going to be 1/4. So when I find the period, I'm going to do 2 pi divided by 1/4. Well, 2 pi divided by 1/4 actually ends up coming out to be 8 pi. Okay, I'm taking 2 pi, cutting it into quarters, and it ends up making 8 of those pi's. Okay, so if you need help on that, please think about dividing by fractions or plugging it in your calculator at this point. So we've got the amplitude. The amplitude is the absolute value of the number in front. So in this case, it's absolute value of -3, which is 3. And that should be in green because that's the amplitude. Okay, so the amplitude is equal to 3. Again, we'll look at how those graph here in a minute. So the period on this one, the period is 2 pi divided by the 2 pi divided by 5. Okay. Well, when I take 2 pi and I divide it by 2 pi divided by 5, I actually end up with a 5. Okay. If you don't believe me, go through the long version. Think about what happens when I divide by a fraction. I have to multiply by its reciprocal. So then I'm looking at the amplitude next. So the amplitude is the absolute value of the number in front. That's a -1 if we put a negative out in front. So the amplitude is still 1 in this graph. The negative doesn't cause us to change the amplitude, it causes us to change the way that we start the graph. So instead of starting this going down, this graph's going to actually start at the bottom and go up. Okay, and we'll look at that when we graph it. The next one, the period here, is equal to 2 pi divided by pi. Well, 2 pi divided by pi is 2. And so this starts repeating after 2. And then the amplitude is equal to the absolute value of -1/4, which is 1/4. Okay? So there's the first set of examples on how to just pick those things out. You have to be able to pick them out before you can actually graph them. So when I'm looking at describing the relationship between these two graphs, I want to consider the period and the amplitude. So in f of x, we've got a period of 2 pi, and I'm going to divide it by 1, so I don't have to actually do that. And I've got an amplitude of the absolute value of 1, which is 1. In g of x, I've got a period of 2 pi divided by 2, which is just pi. And in amplitude of the absolute value of -1, which is 1. So their amplitudes are the same, their periods are different. So g of x is actually going to happen twice in the amount of time that f of x happens. Okay? You can graph these on the graphing calculator to see how that works as well. Okay? Put them in there in the calculator, put both of them in there, and see what's different between them. That's all we're doing, looking at what's different. So I've got f of x. Oh, let me change back to green here. F of x on this one is equal to, or we have the period of this one we want to look at. Period is going to be 2 pi divided by the number in front of the x, which is a 3. And the amplitude is going to be the absolute value of 1, which is just 1. So it's got the same amplitude that it's always had, but it fits in 2 pi over 3 instead of just 2 pi. So then I've got g of x here. G of x, the period, is 2 pi divided by 3 also. And the amplitude is the absolute value of -4, which is 4. So this graph is going to be much taller than f of x. But they're going to happen in the same amount of periods. So the x-intercepts are going to happen exactly the same as we go along here. Now, let's actually look at trying to sketch these graphs. Well, when I'm sketching these graphs, I want to have the period and the amplitude. So if you haven't noticed, that's what we're focusing on in this section. We want to know what the period is and the amplitude. So the period in this one is 2 pi, and the amplitude is the absolute value of -1, which is 1. Okay? So the fact that there's a negative there is going to be important as we graph this, but things that I want to put on here is the amplitude, so it goes up 1 and down 1. And the period, so it's a sine graph, so it starts here at the origin, and it ends out here at 2 pi. So this is going to start repeating. So when I graph these, because it's a sketch, I'm going to be sketching one period of this. So from 0 to 2 pi in this particular case. So now I want 3 points in between. We already talked about why those 3 points. Okay, one of them is pi, one of them is pi over 2, and one of them is 3 pi over 2. Okay, those are the points that we're looking for as we're going to graph this. So now this negative in front, and you can confirm this on a graphing calculator if you want, this graph normally goes up like this, comes back down, and comes back up. Okay, that's what the normal one looks like. That's a normal sine function. But that's not what I have here. I have the sine of negative x. So this graph is going to start, and it's going to go down to -1, and then it's going to come back to 0, and it's going to go up, because that negative in front flips this graph upside down. So this goes down and comes back up, and then keeps going down again. Okay, so there's a nice sketch. This should actually go through this point right here as we're looking. Okay, so I need to plot 5 points on this graph, and those 5 points are going to be important as we're looking and continuing this. So now I'm going to look at the next one. I want the period and the amplitude. So the period in this is 2 pi. There's nothing in front of the x, so I can divide by 1 if I wanted to, but I don't have to. And the amplitude is the absolute value of 3, which is 3. So this graph's going to go up 3, and it's going to go down 3. Okay, it's a cosine graph, so it starts at the top of its function. So it starts way up here at 3. And it has an end out here at 2 pi, because that was the period. So it ends back up here. I want to put in my other 3 places that this graph works. Okay, and it starts at the top, it goes down. So here at pi over 2, it's going to cross. At pi, it's going to be down at -3. And at 3 pi over 2, it's going to be back at 0 again. Now, don't continue this graph up, because this is the top of it. And so we want to make sure that we have this curling at the end, because this graph continues to curl at the end. It doesn't go straight up. Don't draw the lines straight up. Okay, and you're drawing the lines the way that they are going to continue looking as you were to, if you were to continue past these points. And this would go up and come back down and up and come back down. Okay, so make sure that you're putting the up and come back down parts. So now let's take a look at changing the period a little bit. So the period in this particular case is 2 pi divided by pi. So the pi's are going to cancel and I get a period of 2. Well, all that changes is that my sine graph usually starts at 0 here, and it usually ends out here at 2 pi. Well, this time it's going to end out here at 2. Okay, so we're pretending that we're taking this graph and we're actually zooming in to look at just one period of it. Okay, so we take our graphing calculators and instead of them always being the same, we're going to zoom in and we're going to make sure that we're looking at the just one period of this. So then halfway between 0 and 2 is 1. Okay, and halfway between 0 and 1 is 1/2. And halfway between 1 and 2 is 1.5. Okay, so 1.5. All right, so those are the 5 points that I need. And so it starts at 0 and ends at 0 because it's a sine graph. Always starts at 0 and ends at 0. The amplitude, we need to have that. So the absolute value of 4 is equal to 4. So this goes up 4 and down 4. So now this graph is going to go a regular sine graph. Doesn't have a negative in front, so it's going to go up first, and it's going to come back down. It's going to go all the way to the bottom and then come back up to that end of the period. So it goes up, comes back down. And this one actually is going to continue up and it's going to continue down on the ends because that's where the graph actually goes. That's how it gets to the next point. It has to keep traveling in that direction. And so then there's our 4 sine pi x graph. On the next one, the period is going to be 2 pi divided by 1/3. The number in front of the x is 1/3. When I do that, I get 6 pi. 2 divided by 1/3 is 6. And we end up with the pi being up on top still. The amplitude is -2, absolute value of -2, which is 2. So my amplitude on this goes up 2 and down 2. My period ends out here at 6 pi. Halfway in between there is 3 pi. From 0 to 6 pi, halfway is 3 pi. Halfway between 0 and 3 is 1.5 pi. Halfway between 3 and 6 is 4.5 pi. And so we're working on placing these things in the right places. I didn't put the values on the cosine one up on top because they're the normal ones. They're pi over 2, pi, and 3 pi over 2. So if you want those in there, then that's fine. You can put those in there too. So now I'm looking at trying to graph this cosine, but there was a negative out in front. So that negative out in front means that instead of starting at the top, it's going to start at the bottom. Everything is going to be flipped upside down. But the graph's going to go the same. It's going to cross here. It's going to go to the next point up. It's going to cross here. And it's going to come to the next point down. Okay? But it's going to continue that way, continue like this, continue down, and then it's going to continue up again. That's a horrible ending to this. I want to end it properly. So it goes like this, and then goes back up again. Great, so now that's our graph. Now make sure that you're paying attention to the things that I'm paying attention to. I'm paying attention to where does it start, where does it end. Paying attention to places that it crosses in the middle, the 3 points in the middle. Paying attention to the curve where it goes at the ends. And paying attention to the amplitude, how high it goes and how low it goes. Okay? Those are all things that you have to pay attention to when you're graphing these. So you need to take your time, make sure you understand what each one of them are, and then make sure that your graph looks like this. Okay? So now you have a homework assignment that you're going to be looking at, and that homework assignment is on the top of your note sheet, out of your book, and you're going to need graph paper for it, because it's all about graphing. Okay, so make sure you grab some graph paper.